Hello everybody, welcome to the class of Programming and Data Structure at the Indian Institute of Technology Kharagpur in this autumn 2020 semester. In the previous video lecture, I started to discuss regarding the iterations and loops. The motivation for having a loop when a set of statements or group of statements will be executing repeatedly is given. Also, we demonstrated with one C syntax, that is the while loop construct, that how I can put all the repeated statements in one block and then iterate the loop until a condition is proved as false using the while loop. Okay, so in the continuation part we will see two more loop construct and their C syntax. So first, for today's video lecture is the loop for statement. For statement is most commonly used looping structure in C. The syntax of the for statement is given here. So after the for, that is a reserved keyword for C, within parentheses there are three expressions separated by two semicolons. So expression 1 semicolon, expression 2 semicolon, then expression 3. That is the construct for the for loop, followed by statement which will be repeated will be there. Again, similar to while construct, if there is only one statement or single statement, then opening and closing brace is optional. But if there are group of statements, then I have to put all of them inside opening and closing brace. Nevertheless, my suggestion, irrespective of whether there is only one statement for the iteration or repetition or a block of statements for repetition or iteration, always provide a opening and closing brace. Now let us expand this expression 1, expression 2 and expression 3. Okay, so the expression 1 is for the initialization purposes mostly, but later we will see that we can actually make some differences here. So that way the initialize parameter cannot be considered as a very strict thing, but as the construct goes in the next slide, when I will demonstrate the flowchart for the for loop, then you will see that this expression 1 will be executed only once. That's why the name is initialize parameters, and all those parameters which you wish to initialize as part of this for statement or for loop will be placed as expression 1. Expression 2 is for the testing purposes. So test condition, loop continues, if expression is non-zero, all will be placed in expression 2. Expression 3 is for the updating purpose. It is used to alter the value of the parameters after each iteration. And finally, the statement, which is the body of the for loop or for statement, it can consist of only one statement or block of statement or group of statements, and that is called as the body of the loop. In this slide, I wish to demonstrate you the flow diagram for this for loop. Irrespective of whether there is a single statement or block of statement, I am having only one rectangular box for it, and that is the statement or body of the loop. That rectangular box here, the marking is here. Okay, so it may consist of single statement or group of statements. That is not of primary concern here, but let us start from the beginning. So if I start from the top, then following this vertical line, I will first execute this expression 1. Okay, so which is here, and the first expression 1 is before the semicolon. After the execution of this expression 1, then expression 2 will be evaluated, or since there is a condition, so it will be tested If the testing result is true, then it will go this way downward for the execution of the statement or the body, but if it is false, then it will come out of the loop and it will go to the next statement immediately after this loop. Okay. Now if it is true, let us look into that. If it is true, then the statement or body will be executed. After the execution of the statement or body, then it will execute the expression 3. Here the third expression, it will be executed, and that is the update. And after the execution of the expression 3, the control will go back to expression 2. Okay, so this part is basically looping. Now you see the situation. So in the for loop, there are 3 expressions, expression 1, 2 and 3. All 3 expressions are separated by 2 semicolons. Okay. Now this first expression will be evaluated at the beginning of the for loop, when for the first time I am entering to this loop. That's all. It will never be executed after that. Now after the execution of this expression 1, then the condition will be tested. If the condition is true, then only next statement or block of statements will be executed. And after the execution of the block of statements are over, then the control will go back and it will go back to expression 3. So the control will go back for the execution of the expression 3. Please note that it will not go back to expression 1. Okay. So expression 1 will be executed only once when I will enter to this for loop, and after that one it will not be executed. So once the block of statements will be executed, after that one the control will go to expression 3. Expression 3 will be evaluated or executed, then the control will go to expression 2. Follow this flow diagram. After the statement or body, expression 3 will be evaluated. After the evaluation of the expression 3, control will go to expression 2 to check whether the condition holds true or not. If it holds true, then it will come down to that block of statements. This block of statements will be executed, and after their execution it will go to the expression 3, then again it will go back to expression 2. So the looping will be expression 2 block of statements, expression 3, expression 2 block of statements, expression 3. That way it will keep on looping. Okay. Now let us demonstrate that one using one example of computing factorial. This is very simple example. In while loop also we demonstrated this example. So first int main, and then I am declaring 3 integer variables, int n, count and prod, short form of product. Here you can write factorial as a variable name, it's up to you. Next I am scanning, or I am reading from the user that factorial of which number I will compute. After reading that one, I am initializing. Since this is the factorial, so multiplication will take place, and since it's the multiplication, so initialization will be done with 1, not with 0. Please remember that one. If by mistake you initialize this as 0, like our example for sum of n natural numbers, then because of the product, all the result will be evaluated as 0. Okay. So be careful about these small things, otherwise you will find no compilation error, no execution error, but finally the result is not correct. Okay. After initializing this product as 1, then I am entering to the for loop. I am initializing the count variable as 1, then semicolon, then count. As long as count is less than equals to n, then what I will do, product equals to product multiplied with count. Again, although I didn't use the opening and closing brace here, but my suggestion, it is a good thing that if you put this even single statement inside opening and closing brace. After having this condition count less than equals to n, then this product will be computed. Product equals to product multiplied with count. Then after this product is computed, Where the control will go? Control will go back to this count. Now here you can write count equals to count plus 1 or plus plus count or count plus plus. Now you see that this pre-increment operator right now you are familiar with. Since only this operator is alone is being executing here, it doesn't matter whether you write plus plus count or count plus plus or count equals to count plus 1. So that is up to you. Okay, then after this increment operation, then again the flow will go back to testing the condition, that is count less than equals to n. If this condition holds true, then it will come for this multiplication. After this multiplication, it will go for this incrementing the counter, and that way it will keep on looping. And finally, when this condition will not be true, for the instance when the counter variable will increment, and because of that increment this counter variable will be evaluated as more than n, then this condition will be evaluated as false. Then I will be coming out from this for loop. I will print the factorial using this factorial %d and product, and then I will return 0. Now I understand some of you may be thinking that since I am initializing product with 1, then instead of starting from count equals to 1, I can start from count equals to 2. Yes, absolutely fine, that's not a problem. So that kind of small thing you can make some changes, and based upon that one the implementation may vary from one person to another person. Okay. Let us take another example of computing e to the power x series up to n terms. Okay. Now int main, float, x, term and sum, three floating point variables are declared. X, which will be taken as an input from the user, then term, in each step what will be the term value, and sum, the final sum of the series. Again, there is a shortcut of computing this one. You can use some library function, math library function. Using that you can compute easily using one mathematical library call, but we are trying to demonstrate the utilization or use of for loop for several examples. That's why we will not use math library. Instead we will try to use using some for loop. Okay. Now when I am using this for loop in order to calculate the value for e to the power x, or in order to compute the series for e to the power x, then the question is that up to how many terms I should go. Again, at the beginning of our previous video lecture on iteration and loop, so I mentioned that there are two kinds of loop or iterations. One is definite, another is indefinite. So this is one definite situation where I will mention, or I am expecting that the user will mention that up to how many terms I should go. And if I know that up to how many terms I can go or I should go, then I can mention that as the step for computation. So I have to read two things. One is x in order to compute the series e to the power x, and another is n, up to which term I should go for computing this e to the power x series. Now clearly, since n is your number of steps, so n can be integer, that's why n is an integer. I declared one more variable count, which is a loop variable, which will keep on changing along with the change of the loop. I am initializing the term as 1.0 and sum as 0. Again, this is a sum, so safely I can initialize with 0. Okay. Now for count equals to 1, since I know for how many steps I have to iterate, and that is same as the number of terms, so count less than equals to n, this count plus plus or plus plus count, sum plus equals to term. As of now you are familiar with this kind of utilization. So this sum plus equals to term is a short form of sum equals to sum plus term. So you can write either sum equals to sum plus term, or you can write sum plus equals to term. Next, term multiplied equals to x divided by count. Again, this is a short form. What you can write instead is term equals to term multiplied with x divided by count. Now regarding this x divided by count, you please note that x is a floating point variable and count is an integer variable. Since in this arithmetic operation or in this division, one is floating point number, another is integer variable, so always implicitly there will be a typecast, and typecasting will be in the higher side of the representation. So after this division it will be floating point number, so the division will be floating point division. Still, if you are not feeling good with this one, what you can do, you can change this count by multiplying with 1.0 or so that in the denominator also you will have a floating point number. Nevertheless, after these two statements are over, then I am going back, and as per the flow diagram of the for loop, where I will go back to this count. I will increment the count, then I will test that whether required number of terms has been computed and added to the sum or not. If yes, then I will come out of this for loop. If no, then I will add that particular term and I will compute that term here. Another variation perhaps may be that instead of initializing here, you can initialize here. So that advanced representation I will come shortly. Okay. Now after the computation of this e to the power x series up to n number of terms, then I will come out of this for loop and I will print the sum here, and after printing that one I will return 0 and the program will conclude. Okay. Now another situation for computing this e to the power x series may be from numerical application point of view, that I understand that here the user is supposed to mention that n number of terms, up to n number of terms I have to compute. Okay, fine. But situation may demand that there I need some specific kind of accuracy, means that after decimal point I need say up to 4 decimal places it should be correct, or up to 5 decimal places, or up to 6 decimal places. So if that is my requirement, then the condition for the termination of this loop will change. Instead of this number of terms, in that case I have to mention that up to which accuracy I should go. This is to some extent similar to our example where I was interested to compute the double of the money. So initially I started with 10,000 amount, and I wish that in a particular interest rate, that in how many months it will be doubled. So similar to that one, but exactly what it will be is given here in this example. Computing e to the power x series up to 4 decimal places. Again the problems, the implementation starts with int main, float x, term and some similar variables are here also, and int cnt in sort of count, but you can write count also, that's not a problem. And I am basically reading only one variable from the user, that is x. Okay. Now again I am initializing term as 1 and sum as 0, and in the loop part if you go back and check, then you will see that the for loop, I am in the previous slide. So for loop count equals to 1, count less than equals to n, count plus plus. Now this has changed. Now cnt, this you can consider as a count variable. If you change this one to count in the declaration, equals to 1, plus plus count is also there. Only difference is here in the condition. Previously, since the condition was up to n terms, so count less than n was there, where n was taken as an input from the user. In this case, since my termination criteria is that up to 4 decimal places, I need the correctness of the result. So the term will be greater than equals to 0.0001. So up to 4 decimal places, if there is a change in the term value, and that change will be reflected by this condition testing, that term greater than equals to 0.0001, then basically I will terminate. Otherwise, if this is true, then basically I will compute, and if this is false, which means the change of the term, because term is being added to the sum and the value of the term is going to be less than 0.0001, that means it is not significant up to 4 decimal places, then I will come out of the loop. And rest of the two statements inside this for loop are similar. You see that they are not similar, exactly same actually, these two statements for computing the e to the power x. The difference, as you noted here, is that in one situation the user is supplying the number of terms I need to compute for computing e to the power x, and in another situation user is asking, or say the program is set to compute the e to the power x series up to 4 decimal places, assuming that beyond that accuracy may not be significant or may not be required. Okay, so one modification in this case also you can do, that rather another variation of it is that instead of float you can declare these 3 variables as double. So that will be useful if you go for higher accuracy result. So for example, instead of 4 decimal places, if you go for 6 or 8 decimal places, or say when n number of terms in the previous example you are not sure that what will be the size of the n given by the user, then it might be a good idea that instead of float you can declare this x, term and sum as double variable. Okay. Now one interesting observation, as of now probably you have done, but if not, then I wish to point out to the fact that for loop construct and while loop construct are more or less equivalent. In from function point of view they are equivalent, but their implementation is also similar. Okay, how it is, you look at this. So here is the for statement. You see for expression 1 semicolon expression 2 semicolon expression 3, and only one statement is there. I am demonstrating using only one statement, but it will be true for block of statements if there is a opening and closing brace also. Okay. Now you see that for expression 1, expression 2 and expression 3 next statement, what is the order of the execution? When I will enter to the for loop, first expression 1 will be evaluated, then expression 2 will be evaluated, then statement will be executed, then the control will go to expression 3, then the control will go to expression 2, then it will go to statement, then expression 3, expression 2, statement. Here in while loop, if I modify, then I am taking this expression 1 out of this loop. Since it will be executed only once at the beginning of the loop, then there is no point of having it inside the for loop. It can be at the beginning of the for loop also, just above this for loop. There is no problem. Okay. Now expression 1, then while, then expression 2. So this expression 2 is the condition testing. It is inside this while loop. After this condition testing, this statement will be executed. After the execution of this statement, then expression 3 will be evaluated, then the control will go back to this while loop for testing the expression 2 again. Okay. In the flow chart, so these two are same. In the flow chart, if I draw, then it will be looking like this. So expression 1 initialization, expression 2 testing, then statement or body, then expression 3 update, then the control will go back to this expression 2. As long as this expression 2 is true, then it will be looping here. Okay, when this expression 2 will be evaluated as false, then it will come out from here. Okay, so you see that these two are equivalent and actually they are same. Okay. Now here is another example of sum of first n natural numbers, and I will demonstrate the same thing, that while and for, these two loops are same using this example. So you see this example in this gray background, where in the blue color the while loop is there, and you focus only on the blue color region. So count equals to 1, while count less than equals to n, sum equals to sum plus count, count equals to count plus 1, and it will be looping. The same thing is implemented in the for construct. For count equals to 1, count less than equals to n, count plus plus count, that is part of the for loop construct. Then inside that one, sum equals to sum plus count. Okay, so as per the line of statements, there are only 2 lines. In this case there are 4 lines. Nevertheless, the number of times the statements will be executed in both the cases are same number of times both the statements will be executed. So they are actually same, but sometimes we feel comfortable in implementing using for loop, sometimes we feel comfortable implementing using while loop. So as per the convenience, you can use any one of them. So here is one situation where I am demonstrating the advanced expression in for structure or for construct. In the arithmetic expressions, initialization, loop continuation and increment can contain arithmetic expressions. Okay. So in the for structure, basically all those 3 expressions, expression 1, 2 and 3 can have the arithmetic expressions. As of now, in all our examples, expression 1 is always an arithmetic expression, expression 2 is basically conditional testing, expression 3 was arithmetic expression, but this expression 2 can also contain as part of an arithmetic expression, and expression 3 also can contain a part of the arithmetic expression. So here is an example. So initially I am assuming x equals to 2 and y equals to 10, and that initialization is done before this for loop. After this, in this for loop, so for j equals to x semicolon, so this is the expression 1, then j less than equals to 4 multiplied with x multiplied with y, that is my expression 2 semicolon, then j plus equals to y divided by x. Now this plus equals to again is the short form, you can expand it as j equals to j plus y by x, definitely based upon the declaration of x and y as 2 different variables. Okay, if it is integer, then here the division will be integer division. Now if I assume that x and y both are integer variables, they are initialized with 2 and 10 respectively, then this particular for structure is equivalent to j equals to 2 because x is initialized with 2 semicolon, then j less than equals to 80 where 4 multiplied with x, x is 2 and y is 10. So 4 multiplied with 2, 8, 8 multiplied with 10, that is 80 is here, and j plus equals to y divided by x, so 10 divided by x, that is 5. So these two are equivalent, and if you look the second one, then this is simple, and that is the for construct expression 1, 2 and 3, and this particular for construct is evaluated from this for construct, and here it is allowed. But you should keep one thing in your mind, that if x and y is declared as 2 variables, then this computation, like evaluated as 80, 4 multiplied with x multiplied with y, that will be evaluated as 80, or y divided by x, that will be evaluated as 5, that will be done during the program execution, not during the program compilation. Okay, unlike to the situation where there is a macro definition like has defined. So for has defined, the placement will be done during the program compilation, but evaluation will always be done during the program execution. But my intention to explain is that here you can have those arithmetic expression as part of the for structure. Okay, now this increment, since this increment is basically one arithmetic operation, then at this moment I can tell you that this increment may be negative or it can be decrement. There is no need that always it can be just incrementing, rather it can be decrementing also. Okay, And finally, if loop continuation conditions initially false, body of for structure not performed, control proceeds with statement after for structure. This third red color point you can see that is similar to your while construct also. In while structure, if the condition is false at the first occurrence or at the beginning, then the body of the while loop will never be executed. It is true for the for loop also, that if the condition is false for the first occurrence, then the body of the for loop will not be executed. Okay. Okay, after while construct and for construct, now we are in a position to discuss the syntax of our third looping statement, that is the do while statement. So do while statement as per the construct of the syntax is like this. First do, that is a reserved keyword, you have to write that, then statement if it is a single statement, then while expression, okay, semicolon, but I will insist to write do within parenthesis block of statements while expression, okay, semicolon. Now as per the flow chart or flow diagram, so now this particular flow is little different than while construct and for construct. What will happen? So if I consider only this block of statements, then first it will enter to this statement, the statement or statements, or in general the body of this while loop. This is the body of the while loop. This body will be executed first. So you see that after the first entrance, the body of the for loop will be executed. After that one, the expression will be evaluated. If it is true, then it will go back for the second round of execution. If it is true, it will go for third round, fourth round, that way it will keep on looping here. And if it is false, then it will come out. Now just in the previous slide, I mentioned that if an expression 2 in for loop or expression in while loop is false for the first occurrence, then the body will never be executed. Unlike to that, in do while loop, since the statement is executed before the testing of the expression, so at least one execution of the statement is obvious. After that one, it will be decided based upon the expression and its evaluated value whether another round of execution will take place or not. Okay. So here is one example, that prompt user to input month value, keep prompting until a correct value of month is given as input. So the construct is here that do within brace printf please input month 1 to 12. I am suggesting to the user that please provide a month which vary from 1 to 12. Otherwise what will happen? So the user may start typing January, February, etc. or something else, but I want that integer number only whose value is between 1 and 12, because I am scanning for an integer and I am reading that one. Now as long as this month is not within 1 to 12, then I will keep on looping. Now this is one instance of situation where I need the value for at least one time. So this is a perfect use of do while loop, where irrespective of the condition or irrespective of the user input, I have to keep on executing for at least once. So one time execution is over. After that one, I will check whether it is a valid input or not. If it is a valid input, then basically I will proceed. If it is not, then I will keep on asking for the valid input. Now the comparison between do while and while loop. Okay, so just now this is the construct we explained for the do while loop. Do within opening and closing braces block of statement, and after the closing brace while expression. Do not forget the semicolon here. Okay, so semicolon was not there actually for while construct and for construct, but for this do while there is a semicolon after this while statement. Please note this one and be careful about this one. So for this do while statement, the flow diagram is like this, where at least one execution of the block of statements will take place, then the expression will be evaluated. Whereas for while, since expression will be executed fast, so based upon the evaluation, block of statements may or may not be executed even for the at least one. And at the flow diagram also you see the marked difference. So in case of while loop, on the right hand side, then expression will be evaluated fast, and if it is false, it will straight away go out of this one, and statement, loop or body will never be executed. Whereas on the left hand side, statement will be executed fast, and after the execution, then expression will be evaluated. If it is true, then it will loop back. If it is false, then it will go out. Now you can see that since we established that while loop is same as for loop, and there is a difference between do while and while loop, then definitely there is a difference between do while loop and for loop also. So here is another example for decimal to binary conversion, but in this conversation we will print the binary number in reverse order, not in the correct order. Okay, so how I am doing that one? So int main, then integer des is short form of the decimal and is my variable name. I am reading the decimal number from the user as an integer. Then in the do while loop, I am printing that decimal. I am printing the decimal then %2, which means the after dividing the input number by 2, the remainder will be printed. Now you know that how the decimal to binary conversion will take place. So if you do not know, please go through that first. Okay, what is the logic behind computing the decimal to binary number? It will actually keep on dividing the decimal number by 2 until the remainder is 0 or 1. Once you will reach there, then all the remainder in the reverse order, if you read, then you will get the binary number. Now since it is not in the reverse order for this particular problem, or sorry, for this particular implementation, so I am within this bracket, within this parenthesis, actually I am mentioning that it prints binary in reverse order. Okay, so I am printing the remainder after dividing by 2, and what is the decimal number after taking the integer division, I am considering that as a decimal, and it will go on until I will get that decimal number is not equals to 0. Now one thing you can note that this is very similar to our previous example on the last video lecture, where we took the sum of digits of a decimal number. Now last time it was the division by the 10 and it was being added. In this case it is the division by 2 and it is being printed. Okay. Now one more thing at this point I wish to mention to you. You please note that the condition is des not equals to 0. So this kind of condition testing we are familiar with, and we are using this one for almost all the examples. Okay. Now during your implementation, if by mistake you write des equals to 0, then you know that it will be an assignment statement, not a comparison statement. Or when you are doing a comparison like des equals to 0 or not, that kind of thing, if by mistake you make des equals to 0 or des equals to some other value, then it will be an assignment operation, and based upon that one your loop characteristic behavior will change. Okay, so I suggest to be careful about this condition testing, otherwise you may go into infinite loop, that I will discuss shortly. Here is an example to echo characters typed on screen until end of line. So int main character echo do scanf character I am reading as a variable, say ampersand echo, and then I am printing that character until I will reach to /n. By this time you know that /n is the character for the new line. If you look at the ASCII table, then also you will able to find out that /n is there. There are few slash characters. Okay, so this black slash character has a special meaning, and although there are if you count that individually there are two characters, like slash is one character and n is one character, but these are the special thing, and here both are considered basically as a single character. So slash is not considered as one character and in another character, rather slash in is considered as one single character. This is a very simple example. Now the sentinel control loop, one example we discussed on the last video lecture. Here is another example. So in sentinel control loop, receive a number of positive integers and display the summation of and average of these integers. A negative or zero input indicates the end of input process. So input is a set of integers ending with a negative integer or a zero, and output summation and average of these integers. So example is like this. So user will give you 30, 16, 42 and -9. So as per my problem statement, basically negative number indicates the end of the input. So this is an example of indefinite situation where I do not know how many numbers will be given by the user. User can give as many numbers as possible until he will type some negative number. The application of this method is that when a programmer do not know that how many inputs will be supplied by the user, or user suggests that I do not know right now that how many inputs I will give you, so you please write a program and give that to me, then it is always a good idea to go for this sentinel control implementation. Then you will suggest, okay, the programmer, as a programmer, you can suggest to your user, okay, you did not have to mention that how many integer values you will supply to me, but you please I am assuming, and you please supply one negative number to indicate that okay, I am done with the entry to the number. And if that is the situation, then you understand that when say there is a definite loop structure, then the problem is that n is coded. Okay, either n is hard coded in your program, say I am assuming 10 numbers will be input, or you can consider that user will give me the number as an input, that how many integer numbers he will supply. Now in this case there is no such restriction, he will just enter the inputs and the last input will be a negative number. Okay, and this -9 is going to be the sentinel value, and because this is the sentinel value, so after reading this -9 I will stop. Okay, I will assume that end of the input I will finish my sum, I will finish my average, or if there is another computation or other computation, I will finish that one and I will come out. Okay. So this is another situation which may sometimes occur by mistake, and sometimes you may intentionally want to have it, and that is called as the infinite loop. Okay, so infinite loop indicates that there will be no end of the loop, it will keep on looping. So one such example is given here, where count equals to 1, you initialize that one. Now you write while 1. By this time you know if a value is non-zero, then always it is considered as true. If it is 0, then it is considered as false. So when I write while 1, or say while count, since count is initialized with 1, then irrespective of anything it will be non-zero value, so it will be true. Now printf count %d count plus plus, and I will keep on printing. So as long as this condition is true, since you if you write 1, then it will be always true. If you write something, as long as that is true, it will be looping. So if you write 1, then it is always true, and if it is always true, then it will keep on looping, and that is called as the infinite loop. Okay, so here is another example of infinite loop using the do while construct. In this case also the condition is written as 1, it can be any non-zero value. Okay, if it is 0, then it will be false, then it will come out, otherwise it will not come out. Using the for loop, here is one construct. What I have done, this is interesting, that is inside the for loop I just gave 2 semicolons. Now you see these 2 semicolons are mandatory, and that is as per the syntax of the C programming language. So you cannot avoid that one. But expression 1, expression 2 and expression 3 in this for loop, those are optional. You may consider to write or may not consider to write. You may consider to write any one of them, any two of them, all three of them or none of them. But these 2 semicolons are must and you have to keep. Now in this particular example, this for loop construct, okay, whatever is the value of count, whatever is the body of the statement, since the second one in between 2 semicolon, that is supposed to be the expression 2, which will be evaluated as 1, which will be evaluated, and based upon that condition it will be decided whether the loop will be executing or not. Since there is no statement, so it will be in an infinite loop. Another variation of it is that count I am putting is expression 1, this count plus plus I am putting as expression 3, but still that expression 2 is empty, so it will also be an example of infinite loop. Now the question is, if it has infinite loop, then how to get rid of that one? I will come to that one shortly. But sometimes intentionally I wish to put an infinite loop, sometimes this is by mistake. If it is intentional, then I know that how to write that one and for which purpose I am using that one. But if it is by mistake, sometimes I am lost. I see that I am running the program and I am not getting any output. Even the prompt is not coming back. So prompt means that if you are programming using the Linux or Unix, then in the terminal, then $prompt is not coming back. If you are using in any other medium, then you will see that there is a prompt where you have to type the command, that is not coming back. Okay. So in general, this is the structure of defining one infinite loop. Okay. While one, the condition which is inside the opening and closing parenthesis is true, then statement, that kind of situation is always leads to some infinite loop. So 3 different situations using while, for and do while statement for infinite loop. You can have some variations also, but the bottom line is that as long as the condition is true, the loop will iterate. Exploiting that one, if you make sure that always the condition is going to be true, then it will be in a loop situation and it will never come out of that loop. If you wish to come out of the loop, then what you can do, inside this loop statement you can have a break statement. You are familiar with this break statement because in the switch case you have used break, so that after entering to a case statement you did not have to scroll to other case statement or the default statement, but after the execution of that particular case statement or different case statements as per your requirement is over, you will directly come out of that switch statement. Okay. This break statement can be used for while, do while and for along with the switch. But please note that it will not be used for if else statement. So if it is a conditional statement, then you cannot use the break statement. If you even write the break statement inside a if and else statement, then the program syntax wise it will try to identify the closest loop, and when the break statement will execute, then it will come out of the closest loop, that is while, do while or for loop. Okay, or if it is inside the switch. But if it is only inside if and else, then there will be a syntax error during the compilation and compiler will inform you accordingly. Okay. Now causes, this break statement causes immediate exit from a while, for, do while or switch structure. Switch structure, video lecture on the switch structure is discussed extensively, so I am not going into detail of that one. Now the program execution continues with the first statement after the structure, which means it will come out of that loop, and after the closing braces of that particular loop, what is the statement, then it will keep on executing there. Now common uses of the break statement: escape early from a loop, skip the remainder of a switch structure. Okay. Now the situation may demand that okay, you keep on iterating the loop, okay, now until you reach to this particular condition. If the condition is met, then you come out of the loop. So if that is the situation, then break statement may be useful. So break from infinite loop example is here. Now if you do not have this if condition and break statement, then this is a purely infinite loop that you understand. Count equals to 1 while 1, then printf count equals to %d count, count plus plus. If you do not consider these two lines, then it is an infinite loop. Now the moment you incorporate if count greater than 100 break, then what will happen? When this count will go beyond 100, then this condition is true. Since this condition is true, then this break statement will be executed. Because of the execution of this break statement, it will break out of the loop, and that is this while loop, and the control of the program will go from this break statement at the end of this closing brace. Okay. So please note that although it is inside the if, but you remember that break cannot act on if. Since there is a while and this break is always inside this while, that's why there is no error. But if you remove this while and if you just write if and then break, then you will see a syntax error there. Similar to that, there is an example for the for loop also, exactly same as the way I used for the while loop. If count greater than 100, then break. In this case, after the execution of this break, the control will come out and go just after this closing brace. The first statement will be executed next. Okay. So this is another situation for the for loop. Okay, again this for count greater than 100 break. This is another situation for the do while loop. Again, if count greater than 100 break. Okay, and it will come out of this loop. I understand that you may wonder that okay, so if this is the situation, why can't I write that count greater than 100, or say just opposite, if count less than 100, then iterate the loop, say for this do while loop. Why can't I write that count less than 100 here instead of using this break? I completely agree with you. Definitely you can write that one, but this is just to demonstrate the infinite loop for the time being. Later we will see separate uses, and then you will understand that why the break is important. But just to demonstrate that how you can come out of an infinite loop, I am writing this kind of statement. Again, you are right, instead of this break, for this particular loop construct, I can write this count less than 100 as a condition in while or for or do while, and then also these two particular code will be equivalent. Okay. So that's it for today. In short, what we discussed today is basically that two more syntax for C in a loop construct. One is the for construct and another is the do while construct. We demonstrated that for and while is equivalent or same, whereas do while and while there is a difference, and the difference is that in do while the block of statements or single statement or the body of the loop will be executed at least once, whereas for while loop or for loop that kind of situation may not arise also. Okay. So next we will extend this one for some other applications also. Thank you very much.